Do you sit at the table wondering about the food you're eating and why you just can't seem to lose weight or be healthy? Do you stare at labels and have no idea what they mean? Well, we're here today to clear up some of the mysteries of that food label. We're going to talk about fat and tell you everything you need to know.
In an organic chemistry sense.
There are two main kinds of fat, saturated fat and unsaturated fat. For now, we're going to focus on unsaturated fat. Unsaturated fat comes in two forms, a cis isomer and a trans isomer. A cis isomer has the hydrogens on the same side of the chain, as you can see, and they're connected to a double bonded carbon. A trans isomer has the hydrogens on opposite sides of the trains, once again connected to a double bonded carbon.
The structures of the molecules, we can see that cis, because the hydrogen are on the same side, assumes a bent or kink structure. Well, trans fats, when you draw them out, are a linear structure because of the hydrogen placement. This is really important when it comes to the molecules being able to pack in tightly, which is our main concern when we're talking about health factors. An example of this that affects every college student are donuts. So when you look at a donut, they're relatively firm. This is a property of trans fats because essentially what the linear structure of trans fat do make it so that you can pack in more molecules per the area. So that allows food to remain harder or last longer in shelf life. This is in contrast to cis fats, where their kink structure allows more air pockets almost so that they don't pack in as tightly. If you're having difficulties, kind of picture that, just think of Tetris, where you can block in the straight pieces tighter in a Tetris game than you can with other pieces, which would allow more spaces in your game.
I want candy. I want candy. Yeah!
So you may be wondering where trans fats come from. Well, they come from this process called hydrogenization, which is where those saturated fats that I mentioned in the beginning come into play. So a saturated molecule is a carbon chain where it is saturated with hydrogens, as in this one. There are no carbon-carbon double bonds, and therefore there are as many hydrogens surrounding each carbon molecule as possible. Now, manufacturers really like saturated fats because they cause foods to not go moldy as fast. And that's why they try to turn our cis molecules into a saturated molecule. Trans fat is a byproduct of this process. Now, in order to hydrogenate a cis molecule, what you need to do is add heat. But sometimes when you add heat and hydrogen, instead of the hydrogen attaching to the carbons, you're giving the bond, or you're giving the molecule enough energy for this pi bond to break and the H or the whole carbon with the H attached to rotate. And when that happens, you end up with a trans molecule. And this is when you get that linear shape. And this is an unwanted byproduct of the hydrogenization process. And that is where most trans fats come from. There are some that occur naturally in nature, that occur in animal stomachs from the bacteria in the rumen, but most of the ones that we eat in our foods come from this process and are unhealthy.
So you might be wondering how the body actually uses trans fats and cis fat and their linear or bent structure. Now, if we take a cell membrane and the phospholipid bilayer, we can see that when trans fats accumulate in front of them, as seen here, they can pack in very densely. And cis fats, which help maintain the membrane structure, cannot get through the trans fats. This makes it so that the membrane becomes more straight and rigid. The rigid attribute of the cell membrane allows so low-level lipoproteins, better known as bad cholesterol, can enter into the cell membrane and the cell more easily. High-level lipoproteins, on the other hand, which are good cholesterol, which helps our heart, cannot enter. So what does this translate into? This translates into bad cholesterol, increasing health risks like diabetes, heart attacks, clots, and strokes. So essentially, if we have more trans fats in our diets, that's why we're more likely to have bad health effects.
Now, you know why you must avoid trans fats in your diet. As for the other fats we mentioned, just remember that everything is good in moderation. So, go enjoy avocados, nuts, fish, and olives, and try to cook with canola oils and vegetable oils. Don't let those French fries, cup and noodles, donuts, cookies, and other baked goods rule your diet. Else, you will go through some serious linear structure overload. So, what do you choose?